Let's solve another system of equations. In this case, it's 3x plus 4y equals negative 2 and negative 6x minus 8y equals 4. Yeah, once again, I'm just going to enter this into the calculator and see what happens. We'll do edit. Let's see, this is 3, 4, negative 2, negative 6, negative 8, 4. Okay. Quit out of there, run REF. I could press second enter again to pull up this line, but actually even faster than that, if I just press enter, what it's going to do is it's just going to run that previous line yet again, without even me telling what it is. But it's just running that line again. All right, so in this case we get 1.3 repeating, it looks like, and negative 0.6 repeating for the first. That's really sloppy. This is supposed to be saying going into RREF. We get 1.3 repeating, negative 0.6 repeating. We got all zeros for the other line. Let's look to see what's going on here. A quick note, if you end up with things like this, these are not very difficult decimals to deal with because it's just 0.3 repeating. You can go, if you press the math button here, you can tell the calculator to try to convert things to fractions right there. So what it's going to do is it's going to take this value, this answer, and try to convert things to fractions, and you can see we get 1 4/3, negative 2/3. So convert to frac. 1 4/3, negative 2/3, 0, 0, 0. It's kind of a handy trick to be able to do sometimes, telling the calculator to try to convert things to fractions for you. All right, so let's interpret what this says. This first equation says x plus 4/3 y equals negative 2/3. The second equation says 0x plus 0y equals 0. So the second equation, it's not a contradiction, but it doesn't add anything. Saying 0 equals 0, yeah, that's a true statement. Essentially what we have here, this is irrelevant, essentially. It doesn't specify what x is. It doesn't tell us anything about x or y. It just says 0 equals 0. So it's not really contributing anything here. Essentially, instead of there being two equations, what's actually going on here is we only have one equation. You may have noticed that this second equation, if I was to multiply each of the values in this first equation by negative 2, I would exactly get that second equation. And actually this equation here is also that same equation. This one is just slightly rearranged so that we have a 1 in front of the x here. But if I did that nice little trick that we saw, putting things in standard form so that not everything, so that all the coefficients are integers, and all that sort of stuff, you would notice I would want to multiply all three of these by 3. We would get 3x plus 4y equals negative 2, because I would multiply this by 3, giving me 3x, multiply this by 3, canceling out that denominator, giving me 4y, multiply this by 3, canceling out that denominator, giving me a negative 2, which is, of course, exactly that equation. All right, so what's going on here? We have one equation, and we know that when we only have one equation, we have infinitely many solutions. So there are, I don't know exactly what this is going to look like. I'm going to pretend it looks like that, though. I think I'm wrong, actually. I think it should be in the negative. I think it probably should be down here somewhere. Whatever. We have one line. Thus, every single point on that line is a solution, so we have infinitely many solutions. Now, let's talk about how to parameterize this. What I mean by parameterizing the solution This is, you know, it's all fine and well to say that every single point on this line is a solution, so there are infinitely many solutions. But how would we go about finding these individual solutions? It'd be really nice if I could just say, okay, pick a value, or you know, have you tell me a value, and because of that value, me do some calculations and spit out a point that satisfies this equation. And so what I'm going to do is I'm going to say, okay, well, in this solved form, x, you know, this is the x column, and we would say that x has a pivotal 1. This is one of those ones with, if you watch the Gauss-Jordan method, this is one of the ones that we're trying to establish when we're going through this. But y does not have a pivotal 1. Normally, the pivotal 1 for y would be located in this place, but it's a 0 there. We don't have, essentially what it means is one of these rows needs to start with a 1. Whenever one of the rows starts with a 1, we call that a pivotal 1, whatever. Y does not have a pivotal 1, which means y is the parameter. And what I mean by that is that if you tell me a value of y, within relatively short order, I can take that value of y and spit out a value of x that will make this into a true statement. So this x plus 4/3 y equals negative 2/3. If I was to solve this for x, this would just read x equals negative 2/3 minus 4/3 y. So what this means is that if you tell me a value of y, and I plug it in to this expression right here, I can spit out the value of x. And so the individual values of the solutions to this particular system of equation, if we say we parameterize this, it would look like this. It would say negative 2/3 minus 4/3 y, because that's the value of x, and then y, because that's the value of y. And you know, whatever, when we're writing an ordered pair, this is always the value of x, this is always the value of y. And all I'm saying is this thing I circled here is taking the place of the x there. This seems a little silly to do when we're talking about two variables. It will make a little bit more sense when you see the same sort of thing when we have 3 variables. So I'll see you again for that one.